The topic of my talk today is why I feel that India should invest in science and research. And it seems actually a luxury to be able to talk about science and investment in a situation where not only are we going through a crisis now, but India has a host of all sorts of other problems. And I'll address what those kinds of problems are. And why then, in such a situation, should we bother to put in good money in science, or even worse, put in good money in rather esoteric science? Should we invest in mathematics, for instance, studying the stars? Why bother about all those things when we have so many problems around us, and solutions to which can actually be seen by currently available technologies or are really downstream solutions which don't require new science? Or if new science is involved, we can just borrow it from the best places in the world. Why bother to do anything at all? The point I'd like to convey is actually the same can be said of, let's say, arts or music or humanities and so on. In other words, science like art and music and painting is also a cultural exercise, and a society bereft of scientific thinking and bereft of activity in science is poor. And no matter how materially poor we are, we can't afford to be intellectually poor by having large gaps in our areas of thinking. And it would be very, very terrible if India did not invest in the studies of literature, history, language, and so on. And it would be equally terrible if we didn't invest in science. So that's the cultural reason. But next is, in terms of what it means in terms of living in today's world and dealing with it, what science is, what does it actually mean? And also, how does one deal with our environment today in a manner which sustains it, improves it, and makes for development for all our peoples, and indeed people all over the world, in a manner which is tenable in today's environment. So that's what I'll try and talk about. The view that science is irrelevant actually runs rather deep. And the first view is actually what I call the nativist view, that we all want to hark back to some time when things were so much better, and we really fret about how messed up our societies are, and if you could only go back and live in the jungle and gather fruits and perhaps, kill a few animals, but not too much, maybe fish is okay, and we live happily with each other, wouldn't it be wonderful to go back? So that's one nativist view, and that nativist view looks at science as, being against the success over there. The other view is the utopian view, and that, again, is similar to the nativist view, but it harks for a society where, we grow all what we need in our back gardens, we don't commute to work, we live in communes which are very happy and interactive, and, everything goes on quite well, and we live in a world without wars, and everyone is peaceful, and all together we live very happily. It's a nice world to be in, a world which one should attain perhaps, but the fact of the matter is we have what we have and we have to deal with that. So that's, the utopian view. And then there's this dystopian view, which says that, science messes up everything. Look at what science has done. It's made bombs, it's caused, all sorts of, blasts, dysfunctional factories which have polluted our environment and so on. We don't need science at all. And we'll have heated debates on television and people using mobile phones and traveling to the place by air or car, bemoaning what science has done to us. Many of these people, including myself, would long be dead given the average lifespan without science. But doesn't matter, many people have this dystopian view. And then there's a view which is against all that is commercial. Big multinationals are, ruining everything. They've taken over our country and the whole planet. Everything is driven by them, is one view. Governments act at their behest, and somehow science is in cahoots with these kinds of very nefarious activities, and therefore, if that kind of big business is bad, science is also bad. Yeah, let's throw out the wheel with the motor car, as it were. Yeah, but yet science has fundamental meaning for societies. First of all, there is this scientific method. The scientific method is something which is invaluable. It's been practiced directly or indirectly in cultures for thousands of years with value. It has actually triumphed against other ways of looking at the world around us because it is of real practical value, but it's also its elegance allows us to understand nature and the universe much better, right? So the scientific method is fundamentally very, very important. Is the universe the only universe we have? How did it come about? What is the meaning of the planets that we see? When did life originate? How did all this diversity come about? And many of these questions have been addressed with value by the scientific method, and they haven't really been addressed with value by other approaches which are arbitrary. Science, as I mentioned earlier, is also a cultural requirement. It's necessary, I think, for all societies, just as music and art and humanities and social sciences and geography and history are. It's very important. To dismiss that would be very strange. And it's a tool for sustainable development. So the history of modern science in India, though, poses a strange kind of problem. Historically, India had its own way of looking at scientific questions for thousands of years. It had deep connections with the Arab world. It had deep connections with Europe because of a variety of interactions through the Arab world, through the Mughals, and so on. And therefore, there was a lot of scientific activity for many, many hundreds of years in India, and there's no question about that, and there are immense contributions. One important feature of that period of science in India was that it was, in its own way, connected substantially with the society around us. It may not have been a major institutional connectivity. Indeed, science everywhere in the world wasn't a major institutional effort. It was the effort of royalty and so-called gentleman scientists. But those kinds of science actually, by the elite, was actually connected to society in a variety of ways. But later on, there were transformations which resulted in poor connectedness to our society. And that transformation actually started with the British colonization of India and the setting up of presidencies in Calcutta, Madras, and Bombay particularly in Calcutta, where there were institutional structures, universities, the Presidency College in Calcutta first, and then the university, which actually were meant to train Indians to serve the colonial purpose. But as an accidental consequence of that, brilliant young people, such as Jagdish Bose, took upon science as an intellectual exercise in a manner very similar to what was happening in the West. And these were brilliant people, and they did brilliant science, many of the people like Bose and his successors. But the interesting point about the science they did was it was inspired and they were competitive in a world which was centered in Europe, right? And therefore the science which they did, which was world-class, was in some ways actually disconnected with India. But that I don't mean that it didn't address Indian problems. That's sort of a mundane level of looking at it. But it did not have its birth from the Indian society at large in a manner similar to which European science had its origins from its society at large. So this was of high quality, but rather disconnected. So if I can carry on, so that was Bose's origins. And then he and several others did something rather remarkable. I mean, if you look at this list of luminaries, one thing which is outstanding is, if you look at Bose, C.V. Raman, Meghnad Saha, Shanti Swaroop Batnakar, Prashanta Mahalanobis, Haldane, Homi Bhabha, these were not only extraordinary scientists, but they started institutions, right? And therefore, these were people who felt that they wanted to establish the importance of science in the Indian social context and made special efforts to do that. And so this was a major kind of advance which all these people did, and to their credit, that resulted in the movement, as in the West at about that time, of science from being something which was practiced by gentlemen scientists to science which is more inclusive, had all sections of society participating, and actually was institutionalized. So it moved away from being the pursuit of weird intellectuals to an institutional structure, and that happened all over the world. So how then have, in those contexts of these institutions, universities fared? The university system, where many of these people actually started, did not become a hub of scientific research as many of these institutions became. And there are many reasons for that, many arguments, many blame games, and this is not the time to go into that, but I would like to say that it's very important that we have a connectivity between universities and research institutions, no matter what that historical context was. So it's important that we look at new directions, apologies again for that typo, of how universities and research institutions can come together and how one can actually develop the foundations of connectivity of quality science with our society and what these challenges are. Now, what are these challenges that we face in our society? Now, all of us, I mean, merely commuting to work or going back or dealing with our administrations or dealing with our state government or the central government, know one thing for sure, and that's shown in the next slide, that India is impossible. It seems rather overwhelming to us, the kinds of problems we have, the relatively poor infrastructure, the complexities of getting anything done in any system, and in that situation to try and get something done in terms of scientific institutional development seems an extraordinarily difficult task. But that's a task which we cannot ignore, because we are not a trivially small country which can say, forget about this is such a mess, let's fix other things, let's neglect science, because our demography is very, very different from many other countries. We're huge, we're over 1 billion in size, in our population, in number, and importantly, unlike China, for example, a similar demographic pyramid of China would look a little more like a cylinder. If you go to Northern Europe, it'll be an inverted pyramid. And this pyramid structure shows that we have a huge number of people whose growth will result in our average age being 25 very soon. And unless we deal with our society and its intellectual development and its job opportunities and solutions to our problems, we are going to be in big trouble. One point in this graph I'd like to point out that, it's the males on this side and females of that side, and it's a crying shame to see this distribution between males and females. That's a separate topic though. So in this context, we have to ask, what is the role of science? What is the government's view? And what, I've experienced recently moving into the government about the view from within. And if India is impossible, it looks like, as I said, science in India is even more so. And yet, despite that, there's a new perception of the value of higher education and research in the government. And I think this will stay no matter who's in power. There is a very strong feeling that science and technology is very important for the country for a variety of reasons. First of all, social transformation. People feel that, many of our problems can be addressed well by applications of science and technology. Second is economic competitiveness. They feel that if we have to succeed as an economy, science could be valuable in this what's called the knowledge economy. Our environment is a mess. It can benefit hugely from energy and green technologies, and broadly other kinds of environment and ecological concerns which are there as India grows, some of which people accuse science as being the cause. Science also could actually be the solution. But importantly, this last point is very, very important. I think everyone, no matter at what level in the government, no matter how much they stress on applications, see the value of basic research in India. Okay, and that's something which is very unusual, because politically all over the world there is a feeling often of desperation that in times of crisis that one somehow must do something useful, and when things are plenty one must have the indulgence to look at basic research. Very few countries are able to see the value of investing in basic research at a time when things are difficult, because that's what pays off in the long run, and India fortunately is one of the exceptions to that. So let's hope that stays for a while. So how can we build a quality foundation in science? First of all, we have to build up the foundation. And people often ask, why doesn't India have Nobel laureates, or these kinds of successes or those kinds of successes and so on. And that's a very, very wrong kind of question for the following reason. For two reasons. One is, actually, if you look at the quality of Indian science for the kind of investment we have made over the last 60 years, the amount of resources each investigator gets in India is actually quite high. The problem in India is not that we are poorly funding our researchers, but we don't fund a large number of researchers. Our capacity to absorb our funding needs to increase hugely. Now, these researchers who we have funded over the last 60 years, many of them have actually done extraordinarily well. You saw the list of people such as Bhabha and Ramanujam and Satyan Bose and J.C. Bose and so on and so forth. I'd like to contend that in today's India, in the last 60 years, people ranging from Central University, Hyderabad, to Calcutta University, to research institutions, there are actually extraordinary people very similar to those names. The problem which we have is, the reason why they don't stand out is the world has dramatically changed. The world of that time had a smattering of individuals in the West and in India who went into science as a passion, right? And these were individuals in a context where there wasn't an institutionalization of science. So when they excelled, if this is the wall of excellence, there were these few individuals who excelled in a very difficult situation, but they were excelling as individuals. Today, we have built science as a huge institutional structure all over the world. And in this institutional structure, we have many people excelling in labs all over the world who are concentrated near the wall of excellence. There's a large number of excellent people. If you take any given field, there'll be several hundred people who could be, who are as good as any of the other, that several hundred, tens of whom could have got a Nobel Prize, but one of whom gets it. Now, the Indian scientific enterprise in this big scheme of things is relatively small. But given that, I think in any given field, you find one or two Indians who are amongst the top 100 or 200 in the world, and that's fantastic. So I think we should keep that in mind when we look at successes or failures of India. Yet, the foundation is not deep enough. It has to be much larger for a country this size that requires huge amount of investment, and particularly requires huge amount of investment in science teaching at the primary school level, at the secondary school level and the high school level, and in colleges. And that's something which we need to really amplify if we have to have a better foundation. If one actually has to make a global mark, we need to have a team to have few individuals excelling, and the size of our team is rather small now compared to global teams. We need to substantially broaden our base of basic research, and there are two ways we can do this. So far, I would like to contend that we have largely taken problems which are the best problems defined by the best people in the world and try to do a great job on this. And some of us in the country over the last 60 years, again, have excelled in that. But if you look at the way we've excelled, I would like to say it's in the following manner. When our students and postdocs go to the best laboratories in the world, they are full of admiration about this lab from India which did world-class work and sent this young student or postdoc over there, right? Very few labs in the West lose sleep over an Indian lab as being competition. And unless that situation comes about, we are really not, being competitive internationally. So when we work on problems defined by the best laboratories or the best scientists in the world, we should be internationally competitive, or we should define problems from our environment which are of such high quality that they become world-class problems. Both these options are open. We haven't explored the latter option enough, and we haven't put full fuel into the former opportunity enough to be actually internationally competitive as opposed to merely being excellent set of individuals. So basic research is important of both kinds. Our applications, I mean, it's just frightening to see the tremendous number of possible solutions to problems which surround us and how poorly we are actually addressing them. And that again brings me back to the first point I made about the poor connectivity of our science to our society. There are many exciting contrary things happening in our engineering colleges, in our science agencies and so on, which exemplify an increased interaction. But that increased interaction again has to grow hugely. Excellence finally is important. No matter what we do, we must have high benchmarks, whether it's basic research or applied research or research on problems defined by the best labs in the world or problems which we define. We should actually set very high benchmarks. It doesn't, we tend to assume that just because we're studying tuberculosis or malaria, important problems, quote unquote, that somehow the bar of quality is lower for that. They should actually be higher, but we don't impose these kinds of standards on ourselves as much as we should. There's also a sense of purpose which is missing, and we need to have that sense of purpose, and we should move from lethargy, and this is an internal problem, and this is an internal problem which you can often see in the best universities and research institutions. We get people coming in after postdocs in the best labs. They're able to discuss and any scientific topic at any level amongst the best in the world. But you come back and discuss with many of us 5 years later or 10 years later or 15 years later, we're still experts on those problems which we started off. We haven't kept pace with this changing world. And that's an internal lethargy, but we very rarely admit to that. We would always like to blame our system, our disconnect, our resources, our administration, our finance, our distance, and so on and so forth. But unless we actually intellectually drive ourselves, we're going to be a problem. So there's a lot of fault within us as individuals, as scientists. There's also a huge amount of problem with the system, gridlock with a capital G. You know, and this, from the inside of our funding agencies, we can see this happening again and again. At one level, science funding and science institutional management is literally a drop in the ocean compared to what the government does in the big scheme of things. So there's a tendency in the government to try and have blanket rules which look at this big picture and which then automatically get applied to science and technology. And science and technology leads a certain kind of flexibility. So there's a constant battle between science agencies which argue for this flexibility and the government's financial system and management system, which requires a certain amount of, routine rigor, right? If you want to build a national roadway, then there's a way to do it. Due process has to be followed, blah, 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 get this done, next step and do it. That's not the way a science funding situation can be managed. You can't say, here are the list of objectives, you didn't meet objective 1 well, and yet you went and did objective 3, you did a better job of objective 3, but that's no good, where's objective 1? And that's not the way science can be managed, and let alone the science itself. The science financial part needs to be hugely streamlined, so that's a huge problem. Nevertheless, despite all of this, there are tremendous opportunities for India in basic science. There's still wonderful science to be done, which is small science, which individuals in universities can excel amongst the best in the world. India is thought of in the rest of the world as excelling in software, but it can actually excel in mathematics and computer science hugely. The talent is tremendous, that requires investment and training. But this is also true of wet biology. Our society around us, our environment has got tremendous opportunities of all kinds. There are many aspects of experimental biology which can be done in schools, in colleges, in universities, in high-end laboratories, which can make us extraordinarily competitive. But in some ways, this opportunity is also there because of this reason. And by this I don't mean my pigmentation. I'm quite happy with that. I don't think I'm of the wrong color. But I mean the pigmentation which we see on every map. And that is actually an opportunity for science. If you look, for example, at tuberculosis, India is the wrong color. If you look at malaria, India is the wrong color. If you look at dengue, India is the wrong color. If you look at JEV, India is the wrong color. If you look at lymphatic filariasis, again. The next one, children under 5 years with stunted growth. We compare with sub-Saharan Africa, right? If you look at poverty, we're doing horribly. If you look at literacy, also horribly. If you look at corruption, we're doing really well. The next slide. Open defecation, serious problem. Yeah? So we really need to change our color on this map. And that's a tremendous opportunity for basic science and applied science. For humanities and social sciences everywhere. The solutions are staring at us, but it's also true that very high-tech solutions at low cost, implemented across the spectrum, can actually address many of our problems. And I don't have time to go into that, but I think that brings me to a sort of a point related to the Department of Biotechnology itself. In life sciences and biotechnology, the DBT can be this driving force for innovation, connecting, very importantly, with people who have substantial resources and core capabilities and who are actually trying a tremendous amount. The health ministry, the agricultural ministry, energy ministry. And these people, I mean, if you think doing science in India is a problem, dealing with India's health is a phenomenal problem. And despite all your criticisms, if you go and meet officials in the health ministry, you can see amazingly how uniformly its officers are trying to grapple with a whole range of these kinds of problems. And therefore, if innovation can be a little finger on the rudder of those big ships and change its course, it will be of tremendous help and tremendous practical impact. So we really need to do that kind of a change if we are to change this. If we don't do this, we have to ask ourselves, what is the name of this country that we live in? Is it Liechtenstein? If it is so, which is a very small, very picturesque country with hills and hardly any people and big banks making big money, it's fine. We can ignore all these problems. We can ignore science. We can ignore technology. But for good or for worse, the name of a country is not Liechtenstein. It's India. And this is how India is today, about 2010, and that's how it's going to look in 2050. And unless we actually change all these color combinations which we saw, that India in 2050 is going to be a roaring mess. So that's something which we really need to address, and that's very, very important. So we must decide who we are. If we are India, then we have to address these problems. We have to have basic science. We have to have applied science. And we must stop behaving as if we are Liechtenstein. So what is then the role, the next slide, of science and innovation in social change? Does science have a role at all? I mean, after all, if sewage systems are not working, can't we just go and call a plumber and do it at the national level and fix it? Can't we deal with open defecation at a national level and fix it? What has science got to do with this at all? And what is your role in this process? The answer is, I think science, go back to the previous slide, science has a role and we have a role for the following reason. And it brings me back to my first slide about go back to nativist solutions. It's very easy for us to say, the country is in a mess, there's a lot of corruption, politicians are like this or that, and no matter who comes, this is what's going to happen. And this is neither here nor there. This is a constant stating of the problem on one hand, and a demand for an answer which is magical on the other. That all of this has to be fixed, right? And none of these, this stating of a problem again and again, nor a magical answer that, bad roads should go away, corruption should not exist, these are all answers. They are not solutions. Solutions are complex in a complex world. We have more than 1 billion people, we have what we have by way of roads, of people and what they do, and therefore we require actual practical solutions, how to deal with it in the country we have, good and bad, great things and mess, and all of that. There, science does have a possible, very important role. For example, there's a major international competition which was started by the Gates Foundation, But now the Gates Foundation and a DBT public sector company called BIRAC are partnering to address this problem of open defecation. And this international competition looked at toilets and how we can have toilets which utilize energy which is available around and actually don't deal with the city's water supply or the sewage system and burn everything to get back some energy. Okay, and these are the kinds of solutions. If they are implementable on the ground, if they're scalable on the ground, then it will be valuable in terms of a solution. It's not the ideal solution. In an ideal world, one would have fewer people, all extremely well-to-do, and have their fancy toilets, but that's not going to ever happen. So we need to have real kinds of solutions, and our role in this is very important. Similarly, whether it is clinical trials for disease, our diseases are going to be solved by us actually addressing them. Us having a foundation of basic research, taking those results, taking it to laboratories, taking it to animal models, and taking it to clinical trials on our population. We don't have the luxury as a country to depend on clinical trials done elsewhere to have drugs for our population. If we do that, if we ban clinical trials in India and say, until we have perfect regulation comparable to Norway or Sweden, there's going to be no clinical trials in India, then only the rich can afford the best drugs, because the rich can buy whatever they want, the latest drugs they want. It will not reach the public system. So we need to grapple with our regulation. We need to improve it. We need to make sure that the clinical trials are done fairly and there are no violations and they're done correctly. And that's difficult, but that's just part of the solution. Similarly with energy. We bemoan the falling rupee and how much our oil bill is, but yet there are tremendous solutions available how we can deal with these kinds of things internally, right? Again, rather than bemoaning, we must actually work on these solutions actively as scientists to try and change the course of the big ship. Food is another one. The debate has sort of polarized into whether GM or not GM. I think that's a pity, because it's a very valuable debate. There are two sides to that in terms of society and the way industry should go. There's broadly, in my opinion, one side in terms of safety, but yet I think focusing on GM as the end of the debate is wrong. We should focus on the broad use of technology and its development in the country, in our research institutions, universities, to address problems of food, and we're not doing that, and that discussion is important. Vaccinations are another example where there's been recently a 20-year saga which ended in a phenomenal breakthrough in a rotavirus vaccine, and that's the kind of time scale it's needed to develop a new vaccine. And that vaccine required collaborations within the country and outside, and was led by the former Secretary of DBT, Dr. M.K. Ban. And it's an example of staying power which is needed to address our problems. But we need to be prepared to do that. We can't have magical solutions today unless we actually invest in the long term. So are these challenges too formidable for India? And I would say that the answer is no. Despite being a country where we have several problems, next slide, we have a tremendous amount of competence without oftentimes comprehending the bigger picture. We oftentimes neglect addressing problems and their solutions. We are gridlocked and don't embark on new trajectories. Our course system and our curriculum teaches us and not teaches us to be adventurous quite often. We ignore evidence. We somehow magically hope that, tomorrow something will happen, the rupee will slide up overnight, or disease will go away, or something will happen. It doesn't happen. We have to work on these things. And we get trapped, as I said, in nativist ideologies. So in this context, I'd like to end by saying, how do institutions succeed? And the University of Hyderabad is an institution which actually has done well, but how in general do institutions succeed? And they succeed usually in hindsight. You have a large number of institutions and you pick the one which has succeeded and say, wow, someone did something there which was very good. But is that winning the lottery, or was it actually a plan? So if you look at the University of Hyderabad, how can it succeed even more than it has? The odds apparently are stacked against us in the complexity which we have locally and everywhere else. But these odds are stacked against us only, the next slide, if we calculate the odds in today's world. We can't predict tomorrow's world, and the odds may be changed. So therefore, an educational system which prepares us for any eventuality, which keeps us nimble, will allow us to succeed beyond our current odds in tomorrow's world. And that's very important, and we can do, if we are prepared in a system to be adventurous as the world changes, I think we can do extraordinarily well. Doing well requires different kinds of people. It requires 4 kinds of people: people who are visionaries, people who manage the institution well, people who are the moral compass of an institution and keep it on the straight and narrow, and finally people who are willing to see opportunities of change and push the institution into difficult new directions in a changing world. And I think all of our institutions do have these kinds of people. It requires these people to merge individual and institutional agendas. People have their own pride, they like to succeed, but the institutional agendas can also, encompass that, and both can do well. So excellence, therefore, has a shared purpose. And I'd like to end by saying that this shared purpose in a university environment can be done by following 6 lessons, which I was very impressed by listening to a talk by Charles West, the former president of MIT in Okinawa a few years ago. And Chuck West said that in a university, teaching and research must be intimately intertwined. There's no such thing as a good teaching university or a good research university without the other. The quality of research is determined by its faculty. I mean, there's no magical way by which you can have few individuals who excel in research without the entire faculty not being of substantial quality. Science must function in an open environment like which you have over here. It's difficult to have an open environment. There's debate, discussion, there's all sorts of problems, but there's no compensation for an open environment. That's what makes a university a university. Young faculty, therefore, in any university environment, should be free to study and teach whatever they believe is important. You don't impose directions from above about what should be taught in a curriculum or not. Science should be taught scientifically and not by some externally imposed agenda, and different schools of humanities and discussion should flourish. Competition is very important, both within and outside. Sluggishness comes from deciding that you're the best and you know all the answers and making more and more demands for yourself without seeing yourself in a competitive world where actually you are. And one assessment about how you're doing competitively is to ask in the morning when you're having a cup of coffee, ask yourself quite honestly, who would hire you if you were to go away to another institution? That gives you a measure of your individual competitiveness. And if you want to ask how your institution is doing, ask who would come to your institution. What is the quality of people who would come to your institution? That gives a measure of the institution. So forget about impact factor and metrics and so on and so forth. Who will give you a job and who wants to have a job at your place? If these are people of quality, then you're doing well. If not, we need to do better. And that's a question we must really ask ourselves. So fundamental scholarship and research must exist on an equal plane with applied research, and universities should be the bulwark against pressure to do something one or the other. Just do something which is excellent, no matter whether it's applied or basic. Thank you very much.